was disgusting performance, I am of course doing another hard problem because I saw daily problem is hard, and I checked and it's was asked at Google in some past time. So let's try this. I have time. It's like 4 p.m. even though I did not know much today, but who cares. One base binary matrix, 0 represents land and 1 represents water. Okay, so everything is land. Okay, so something top to bottom by walking on land cells. You can either start from any cell in the top row top to bottom by okay. So my first idea would be to do some sort what I'm thinking is that if we could simulate the flooding, and then like after each iteration we can just do BFS. But if we have many of these cells, right? Yeah, so basically all of them are gonna get flooded. So that sucks. Therefore, we don't want to do that. If we could determine that, because if this floods, it really doesn't change much. Like if this floods or this floods, well, what that means is that in the component that was possibly created, we want to know if there is both the leftmost and the rightmost. If there are, then they have to be somehow connected and you cannot pass through. So for each component we could store the leftmost and the rightmost. Element, and for that we could use union find and just store it in the leader, and that is disgusting. That is simply disgusting, bro. But it will work, and each time we merge, like if there are no neighbors, or if it was merged with something, we just merge it with everything and then see if the resulting component has both left and right, and then we cannot pass through. If some components has cells in the left column and right column, then it has to be connected. Even if it's like that, it still has to be connected. So we need a union find. Let's do that. Class union find public private, I guess, and then vector int parent, and then I don't use rank, I use size, and then let's call it velc because, or season sys and par. It's annoying to type just sys, but whatever. And each has size 1, and then we want to do iota par begin par end from 0, and that's it. And then we want to have find like that, and then we want to unite this as path compression. So there was no int unite if size of x is size of y. We want to merge the smaller one into the bigger one. And we want to hang it there. And return true, because for now that is, technically I guess I don't care. I can't type today, making many mistakes. My keyboard is off. So after, so that's our union find, and then what's row call? Okay. Oh, but we have 2D union find. Bruh, hell nah. And we also need to store the left and right. Hell nah. Bruh. Row, call, row, call. Size is n times vector int. This is number of rows. Could do it one dimensional, but who cares? Parent of this is himself, and then we can define pairs for readability. So let's say we get 1, we get 2 of these guys. So we get one element, another element, and check if they are in the same. This x, find x, size of x first, x second, y first, y second. That, and then parent of y first, y second is equal to x. Yeah. If x is parent, return this. This should work, I think. We just need to change this. So vector int is size parent. Fair enough. And then we create a union find uf row call. Let's call it small uf, and then we go through cells. So I still did not add the left right, so left ij is j, it's also right ij, so the rightmost in that component is that. Okay, and then we're gonna do left assign row vector int call does it matter? Call right. Okay. We mark the marked. This is not really a hard question in the idea, just with the data structures. So let's go for the cells. R, C0, and column is 1. Now we wanna go through row call, and he's finding his parent. Then I want to do left x first, x second is min, left x first, x second, and left y first, y second. Right. Like that. Let's see if we have first like that. So we go through the name, so we want to do marked RC int new row plus d row, should be d row and dc, do not confuse. So let's do d row d. The new column is column plus dcd. If this is over 0 and this is over 0 and a row under row and column under col and marked new column new row, then we unite make pair RC new row new column, okay, and then so leader is find okay, and now we want leaders left and right, so let's call it blocks. So let's not use bool, blocks, return right should be max, return right x minus plus 1 is equal to number of columns. I guess. Iteration. Int iteration 0, return iteration, return iteration plus plus, return minus 1. This might work. UF unite, and this is UF find, and UF blocks, and then we got the runtime error. All my days. Okay, where? Bro. Oh, parent is not resize. Okay. Interesting. Oh, we die here. So, okay, wrong answer for this guy. Also, we want to go through all of them. Minus 1, minus 1, minus 1, 0, 0, 1, 1, 1, 8, and then this is that sucks for sure. 20 minutes. I have to debug this because we make this guy. Connecting R here is a typo. I think I would never notice that. Okay, still one result wrong. And R. So first I am connecting nothing, then 1 0 to 0 1. So these two are connected. Then a new line, this and new line, new line. I'm missing here a number. Now it should pass. Great. So this, boom, boom. Now this should pass. Easy. Great. We are in top part of the solutions. Maybe if I run it multiple times it will jump. No, it won't jump there. I'm at 79. Okay, let's write up a solution. Union find. The water creates components. The components, a component blocks all paths from top to bottom if when does a component block all paths from top to bottom? If it contains an adjacent even diagonally, since we cannot cross the diagonal waters. Also, if it contains adjacent water cells, if it contains adjacent water cells in each column, i.e. It spans the whole width of the grid. Obviously, checking if the grid is passable after each cell after it is flooded is slow. So what if we could check the currently watered cell can connect into a component with adjacent even diagonally adjacent watered cells. For each component, it's enough to store the leftmost column any of its cells occurs in, leftmost and rightmost columns any of its cells occur. How can we simulate this fast? to the union find. At the start, each cell is its own component. If it gets watered, we try to join it into components of all of its 8 neighbors. There is 8 of them. All of its 8 neighbors. Afterwards, we check the leader of the component. When joining two components, the union find, we have to update. We also have to update the left and right most columns of the new component. It's just a minimum of the original components values, minimum / maximum. Find leader has the same implementation as in usual union find with path compression. After we merge it with all watered neighboring components, we check if the final component of the current cell spans the entire width of the grid in O1 by checking right minus left plus 1 equals call for the leader of the component. Time complexity is tricky, but space is row call. Since we store parent leader for each leader, size of component, leftmost and rightmost column of the component corresponding to each cell. Okay, time complexity is going to be a little tricky, but worst case it floods after row times column minus 1, so everything except one column. And so worst case is another new user, Austria. Yeah. So worst case is we need to flood row means call -1 plus 1 sales, which is O of row c.call. For each of the floodings we do constant number of merges of components, each in Ackermann. It's like alpha and time, and one find in the same row call since if we use the best union find algorithm, which has a time complexity of alpha n, where n is the number of elements, is the total number of elements, which in our case is row call. Our final complexity is therefore row call alpha row, something like this. Fair enough. Publish. So 32 minutes for hard problem. That's not terrible, and I coded union find out of my ass. Goodbye. Happy New Year.